Welcome to 5.4 Sum and Difference Identities for Sine and Tangent, Example 4. Suppose that A and B are angles in standard position with sine A equals -3/5 and A is between over 2 and 2 pi. And cosine B equals negative, where B is in between pi and 3 pi over 2. A, find sine of A plus B. Sine of A plus B is our sine sandwich formula. So now we need sine and cosine of both A and B. Since A is in between 3 pi over 2 and 2 pi, we know A must be in quadrant 4. And we're told that the sine of A is -3/5, so the y is -3 and our r is 5. Of course, you could instead do the Pythagorean identities for these, or we could figure out using just the Pythagorean theorem that x squared plus 3 squared has to equal 5 squared, and we'll get x equals 4. It's actually plus or minus 4, but since the x is positive here, we know it will be 4. So here we have sine is -3/5 and cosine is 4/5 for A. Now for B, we have a totally different angle. I had a typo up here. We have B is in between pi and 3 pi over 2. So B will be in between pi and 3 pi over 2. So that's in quadrant 3. Cosine of B is -7/25. So the x is -7 and the radius is 25. So to solve, we have to find y squared plus 7 squared equals 25 squared. 25 squared minus 7 squared is 576. We square root both sides, so we get y is plus or minus 24. Since I'm in the third quadrant, my y value is -24. Therefore, my sine is -24/25 and my cosine is -7/25, as was stated. So now I'm ready to plug in the values of the sines and cosines of A and B, just making sure that I'm careful where I place them. Multiplying each straight across. On the left, we get 3 times 7 is 21. A negative times a negative is a positive, and 5 times 25 is 125. On the right, we get 4 times -24 is -96, and 125 on the bottom as well, which verifies we are on the right track. Now we add them together. -75 over 125, reducing gives us -3/5. Part B, tangent of A plus B. I moved the information over here. So first we use the formula for tangent. So for tangent of A, either you could have used the triangles, or tangent is also sine over cosine. So I could do -3/5 over 4/5. The 5's cancel and we get -3/4. Similarly, for B, we can do sine over cosine. So we get -24/25 over -7/25. The 25's cancel, the negatives cancel, and we get 24/7. So we have the tangent of A is -3/4, and the tangent of B is 24/7. So for the first fraction, I can multiply top and bottom by 7. And the second fraction, I'll multiply top and bottom by 4. And on the bottom, I need to still multiply these two fractions. So I get 1 plus 72 over 28. I'm not going to reduce any of these fractions just yet because I have everything has a denominator of 28. So I will rewrite the 1 as 28/28. Therefore, on the top, I get 75/28. On the bottom, we get 100/28. And in fact, the 28's cancel and I get 75/100. We could get 3/4. So therefore, the tangent of A plus B is 3/4. Now we need to find the quadrant of A plus B. Well, let's see what we know about A plus B. We first found that the sine of A plus B is negative because we got -3/5. We also found that the tangent of a plus b is positive because we ended up here with a positive 3/4. So a plus b is its own angle, but we know the sine is negative and the tangent is positive. So now we have to think, where is that possible? So sine is negative in quadrants 3 and 4 because our y values are negative, and tangent is positive in quadrants 1 and 3. So if they both have to be true, the only quadrant they have in common is quadrant 3. So therefore, a plus b is in quadrant 3. I hope you enjoyed this video. See you next time.